All right, hello everyone. Today we're going to solve LeetCode 200 number of islands. Given an n by n 2D binary grid, which represents a map of ones, land, and zeros for water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume that all four edges of the grid are surrounded by water. So I'm going to quickly show the first example and why this is the answer. So let's say we start off at the origin point 0, 0, and we want to find all connected pieces of land horizontally and vertically to 0, 0. So what we're going to do is mark the first piece of land that we're at, and we're going to look all four directions and see, do we have land in any of these places? And see, we can find all of these pieces of land either going up, down, left, or right. And from the origin point, if we go down, this is land, land. If we go right, land, and land. After we've found all connected pieces of land to the origin point, we're going to increment our count up. So now we have a count equals from 0, it's going to go from 0 to 1. So that means there's currently one island. And we check the grid and we see, hey, there's no more pieces of land that haven't been explored. Therefore, we've checked every single piece of land and we've only found one island. So the answer is 1. If we look at this next example here, same story, we start off at the origin point 0, 0, and we see, hey, it's equal to 1. So this is the start of a new piece of land or an island. So we explore the first point and we look at all pieces that are connected horizontally or vertically. So all four of these in the top left-hand corner, and this will count as one island. Next, we keep traversing the grid and we come across this piece here. We traverse it and we look up, down, left, and right, and we say, hey, we can't actually go anywhere. So this is an island all on its own. And if you're wondering why we can't get to this island here on the bottom right-hand corner, it's because it is horizontally connected and we only can go up, down, left, or right. So that is not allowed. So this is its own island. So +1. And then lastly, we have the one on the bottom. We start off here. We can't go to the left because that's water. We go to the right, we check and we see, hey, that's land. And we see that that's all of the pieces of land that are connected to the origin point of here. Therefore, that is the last island. And we've traversed the whole grid and every single piece of land has been accounted for. Therefore, the output is 3 for 3 islands. All right. So that's why the answer is right, and a little high level overview of the algorithm we're going to be using. So in graph problems, usually you solve them either with breadth first search or depth first search. In this example, I'm going to be doing depth first search or DFS. And we're going to traverse the grid. And every time we find a piece of land, what we're going to do is start off at that piece of land, turn it into a 0, which means it's water now. You might say, hey, why are we doing that? Because we don't want to count the same node or same cell twice. Let's say we start off at 0, 0, and then we went over to 0, 1, right? How do we ensure that we don't go back to 0, 0, then 0, 1 again and have an infinite loop? What we can do is just change every node that we've traversed to a 0, which means it's water, so we won't check it again. And eventually, the whole grid will all be zeros, and every piece of land will be accounted for, and will return the number of islands that we found. All right. So that's essentially the whole entire solution. So I'm going to quickly show you guys how to do this. And just as a little tidbit, the way that we check to make sure that we don't traverse to the same cell twice, what I did was change each cell we traverse to a 0, which means we won't check it in because we're only looking for land, and that would be water now. But what you could do is also use a set and store the coordinates of cells you've traversed to, and then just check if the cell you're going to traverse to is inside of scene. Each way works, but I like the changing the value to a 0 because I believe it's a bit more simple. So I'm gonna quickly go over how to read code something like this up. All right, hello everyone, we're back. The audio got corrupted, so I'm re-recording the solve. So first, to solve a problem like this, since we're gonna be iterating through the whole grid, what we're gonna do is to know how long the grid is, how many rows and how many columns. So we're gonna store it in a variable called rows. So we're gonna say rows equals the length of grid. And we're gonna say columns equals the length of the columns, or grid at 1. So you can see the rows, there's 1, 2, 3, 4. So that's the length of this whole entire grid. And the columns will be the length of the first element in this grid. So this sublist. So 1, 2, 3, 4, 5. So there's 5 columns and 4 rows. All right. So now, next, what we want to do is we want to have a variable called count, because count's going to be how many islands we found. So count equals 0. Next, what we want to do is have a directions tuple, and we're going to call it direct, and it's going to equal a tuple. And essentially what we're going to do is have it go all 4 cardinal directions, because we can go either up, down, left, or right from any cell. So let's say we're at 0, 0, and we want to go to the right. We would have to add 1 to the column, because we'd stay on the same row and add 1 to the column. So this would be 0, 1. And to go down, we would have to add 1 to the row, because it's going up a row. So I'm going to quickly write that down here. So our first tuple will go up. Let's say up. So that means to go up, we want to go -1 to the row and keep the column the same. To go down, we want to add 1 to the row and keep the column the same. To go left, we want to keep the row the same. And subtract 1 to the column, because we want to go backwards in the column. And lastly, to go right, we keep the row the same and add 1 to the column. There we go. So we have our directions. So next we're going to create our DFS function, and we say I define a function called DFS, and it takes a row and a column, which essentially is going to be the starting node. So let's say it was 0, 0, and we're going to iterate through our direction tuple, and we're going to go left, down, up, and right, and say if we find land, we're going to go to that cell and call DFS on it, and then travel from that cell until all of the cells that are connected on this landmass are all been seen and been turned into zeros. All right. So first we have to iterate through directions. So we have to say for row, comma, column in direct, new row, which is just the new row, will just equal the current row that we're at plus R. And the new column will be the current column that we're at plus C. Because let's give an example here where we want to go up. So if we started off at 0, 0, we'd add -1 to the row and do nothing to the column. So if we're at 0, 0, if we add -1 to the row, that means we are going up. There is no way to go up because this would be -1, 0, which means we're out of bounds. But the same thing applies if we were going down. We would, instead of subtracting 1 from the row, we'd add 1 to the row. So it would be 1, 0. Just like we have here, 1, 0. All right, next. And that was a little bit of a foreshadowing of what we have to do now. If we were to go up from the point 0, 0, that would be out of bounds and we get a index out of range error. So to avoid that, what we're going to do is have a condition that makes sure that whatever the new row, new column is still inside the grid. So we're going to say if 0, it has to be less than or equal to new row and less than rows. And I'm going to quickly explain why this makes sense. So if our new row, it has to be, the index has to be greater than or equal to 0 because 0 is the first element inside of an array. And the max element it could be is anything less than the current rows. So if the current rows length is 1, 2, 3, 4, the row has to be anywhere that's less than rows because remember arrays are 0 index. So anything 3 or less, because 0, 1, 2, 3, that's the range that are of allowed values for our rows. And we're going to say that do the same exact thing for columns because we can have less than or equal to 0 because that's what we want our new column to be. And less than calls. Same thing, same idea here for a column. Since we have 1, 2, 3, 4, 5 columns, we need anything that's 4 or less because it's 0 index. And there's actually one more condition. We need to make sure that that current cell that we're traveling to is land because we don't want to go into the water. So we can say new row, new column is equal to 1, which means it's land. Perfect. So now that we know that we're at land, what we're going to do now is say grid at new row, new column is going to equal 0 because that means we've already traveled there. It's just like if we start off at 0, 0, once we've traveled to this point, we don't ever want to go back to it. So we can just turn into water, i.e. we've traveled to it as we traverse through the grid. So that just means, that just ensures we don't go back to the points we've already been to. And next, we want to call DFS on the new cell that we know is inbounds and we know that has land. So we're going to say grid, or we're going to say new row, comma, new column. Perfect. So every time this DFS function is called on a row and column, it's going to go and look up, down, left, and right and see, hey, is this inbounds? And if it is, we're going to check now, hey, is that grid cell that's inbounds land? And if it is, we're going to change it into a 0, which means we traveled there. Then we're going to call the same function recursively on that cell, and it's going to keep going until all the cells have been seen. So just like in this example here, it would go until every cell in this island turns into water. And then we would increment 1 to our count, right? That's what that DFS function is. So now we actually have to call that DFS function every time we see land. So we're going to say for row in range rows, and remember rows is just the length of how many rows we have, and for call in range calls, if grid at row call equals 1, which means it's land, what we want to do is call the DFS function on the row and the column. And that means we found a piece of land. It's going to go find every connected piece of land to that land and change it into a 0. And remember, since we found land, that means that that is the start of an island. So we're going to say count plus equal 1. And now all we have to do now is return count, something like this. And let's actually try it out. Hopefully we haven't made any mistakes. Runtime error. What happened? Oh, apologies. I wrote equal to it. I was assigning a variable. Make sure to use the double equal sign there. And let's submit. This is a quick typo. I tend to always have at least one of those. And there we go. We've solved the question, and it's pretty efficient. So just make sure you only use the single equal sign and don't mess up like me, and you should be good. Peace.